All right, let's take a look at this differential equation, y double prime plus y, 1 plus x y prime minus y equals 0, as a series about x equals 0. I'm going to do part 4 first. Based on the differential equation, what is the minimum radius of convergence for the power series? Okay, so we've got the 1 y double prime in front. We have no problems with this. It does not blow up, so that's fine. Negative 1 is a very boring function also. That doesn't have any singularities or discontinuities. And so the minimum radius of convergence is going to be plus infinity. These terms don't have any singularities, and so we can say without doing any computations that the series that we get will converge for all values of x. Okay, now the hard work. Let's find the recurrence relationship for the coefficients. So for starters, we have that y is equal to summation n equals 0 to infinity of a sub n x to the n. Okay, now I have a y prime term, so y prime is going to be equal to summation n equals 0 to infinity n a sub n x to the n minus 1. And also y double prime is going to be equal to summation n equals 0 to infinity of n times n minus 1 a sub n x to the n minus 2. Now we'll employ the standard trick to get this one in terms of x to the n. So summation n equals 2 to infinity n times n minus 1 a sub n x to the n minus 2, because the 0 and 1 terms disappear. And then I re-index to get n plus 2, n plus 1 a sub n plus 2 x to the n. Also, I will re-index on this one by the same trick, summation n equals 1 to infinity n a sub n x to the n minus 1. And then re-index, I get n equals 0 to infinity of n plus 1 a sub n plus 1 x to the n. Okay, that accounts for most of the terms. I've got a y double prime, I've got a 1y prime, I've got the minus y, but I also have the xy prime term, so let's write that out. Xy prime equals, multiply this by x, I get summation n equals 0 to infinity n a sub n x to the n. Okay, so let's construct this. We need to get y double prime plus y prime plus xy prime minus y. Okay, now everything here is from 0 to infinity with x to the n's, so that's nice. Y double prime is going to be this part here. Summation n equals 0 to infinity n plus 2 n plus 1 a sub n plus 2 x to the n. Plus y prime is this part, plus summation n equals 0 to infinity n plus 1 a sub n plus 1 x to the n. Then plus x times y prime plus summation n equals 0 to infinity n a sub n x to the n. Then minus y is this original one here, so summation n equals 0 to infinity a sub n x to the n. So that's supposed to be equal to 0, and then I can combine all of these. Summation n equals 0 to infinity n plus 2 n plus 1 a sub n plus 2 plus n plus 1 a sub n plus 1 plus n a sub n minus a sub n x to the n. And so the thing in brackets has to be equal to 0. So that gives me that n plus 2 times n plus 1 a sub n plus 2 plus n plus 1 a sub n plus 1. Not factor this out, I get n minus 1 a sub n equals 0. And so solving for a sub n plus 2, I get negative n plus 1 a sub n plus 1 minus n minus 1 a sub n all over n plus 2 n plus 1. And let me split this up into two fractions. A sub n plus 2 is equal to negative a sub n plus 1 over n plus 2 minus n minus 1 over n plus 2 times n plus 1 times a sub n. Now, as usual, let's write this as a sub n equals something to make my life a little bit easier in the future. A sub n is going to be equal to negative a sub n minus 1. Everywhere I see an n, I'm going to replace by n minus 2. I see n replaced by n minus 2 minus. I see this n replaced by n minus 2 over n times n minus 1, a sub n minus 2. And so this one, each term in the sequence is going to be determined by two previous terms. So coding this in Excel is going to take a little bit more work than some of the other examples that we've seen. So let's do this in Excel. This can be programmed in Excel. Okay, so A, B, row 1, row 2, row 3, row 4, and so on. So this is going to n equals 0, and then I will fill down here to get 1, 2, 3, 4, 5 in these cells. In column B, entry A1 and A sub 2 go here, A sub 0 and A sub 1 go there. Then my rule for term A sub n is going to be minus A sub n minus 1, so the one that's 2 back, divided by n, A3, minus n minus 3. Now I'm not going to go do that, so let's do this as A3 minus 3 divided by A3 times A3 minus 1. I could have put A2 here, that would have been all right, times the term that's 2 back, so B sub 1. Then if I were to fill that down, that would allow me to automatically compute the first few terms in the power series expansion. Okay, now let's talk about the rest of this problem. Part 2 of this problem is kind of unusual. It says, to show that no matter what, values of a sub 0 and a prime of 0, that's code for a0 and a1. No matter what you choose for a0 and a1, the coefficient of y to the fourth in the solution's power series expansion will be equal to 0, no matter what. So let's see what happens. So there's our recurrence relationship. So let's see what happens. A sub 2 is equal to negative a sub 1 over 2 minus 2 minus 3 over 2. That's 2 minus 3 over 2 times 1, a sub 0. And so what does this work out to be? So this becomes plus, that's a minus 1 for plus a sub 0, then minus a sub 1, and everything is over 2. So a sub 2 it works out to be equal to this. A sub 3. A sub 3 is equal to negative a sub 2 over 3 minus, well, if I plug in 3 into this, I get 0 over 3 times 2 times a sub 1. So it's minus a sub 2 over 3, so it's just going to be minus a third times what I got here for a sub 2. So that's negative 1/6 a sub 0 minus a sub 1. All right, now the problem says that a sub 4 is supposed to be equal to 0, so let's see what happens. Minus a sub 3 over 4, minus plugging in 4, I get 1 over 4 times 3 a sub 2. So minus a sub 3 over 4, that becomes 1/24 a sub 0 minus a sub 1, multiplying a sub 3 by minus a fourth, minus a 12th times a sub 2, which is a half a sub 0 minus a sub 1. So I get a 24th of this minus a 24th of that. And so sure enough, a sub 4 always turns out to be 0 no matter what. So that is part number 2. Number 3, describe how a computer program can compute the coefficients. We did that earlier. And so this one doesn't have a very simple closed form solution, but it can be computer program can find as many coefficients as you like in fairly short order.